So this is the ARMS project. It is a joint venture between NAVSEA and Naval, and it leverages a Microsoft HoloLens to generate a remote collaboration environment between a shoreside subject matter expert and a shipboard maintainer. And in this environment, they can see each other and interact visually with audio and with holograms that can be placed into the field of view of the maintainer to help troubleshoot and maintain Navy equipment on a ship. Currently it's in development, but this coming summer it'll be on an aircraft carrier for a demonstration period, and then next year we'll have it installed on several destroyers for an extended trial period.
So today we're demonstrated the Augmented Reality Remote Maintenance Support Service, or ARMS, developed out of Naval Lakehurst. I'm with my colleague Aris Stakos. He's wearing a Microsoft HoloLens 2 headset, and that provides augmented reality video and audio for maintainers. And I will be representing the subject matter expert side when we demonstrate ARMS here in the exhibition hall. Now I'm going to represent the subject matter expert, so this would be the SME console, and essentially whatever you see here is what our maintainer sees. So Aris is in the hall walking around, but we're going to kind of act like we're doing maintenance. So any video that you see here is coming out of Aris's headset. He can hear us, we can hear him. We can text if we lose or maintain audio video. And we can also place holograms. So if I wanted to have Aris look at this one particular location on a piece of equipment, I'd say check this pin. And the hologram would be placed in real time in that location, and it will stay there statically. So you can imagine if you're trying to teach someone how to do maintenance or show them how to do maintenance, you can place these all over all the part and guide them one step at a time. So the ultimate goal of ARMS is to minimize travel for the Navy, Air Force, Marines, all the services. It's never been more necessary because of the pandemic. Everyone realizes that the ultimate goal is to minimize travel and save money, and that's what ARMS aims to provide. We'd like to provide real-time maintenance support at a fraction of the time, fraction of the cost. That's the ultimate goal.
So the classic lithium-ion battery container is a solution for the safe transport, storage, and charging of lithium-ion batteries aboard ships and other DoD platforms. The way it achieves this safety is through subdividing the stored batteries into these smaller compartments. And that way, when we have a failure of one battery, it doesn't spread to the rest and cause a serious fire incident. So in addition to just the passive storage in these smaller compartments, there's active fire detection and suppression in each one, in addition to charging infrastructure, so the batteries can arrive to the theater fully charged and ready to use by the warfighter. So these lockers can contain a number of different batteries, anything from the smaller ANPRC radio batteries to something like the BB2590 that would be worn on soldier or Marine kit, all the way up to something like the lithium-ion 6T automotive battery that is used in combat vehicles. So each of these lockers would either hold one large battery or a number of small batteries, and it would either be equipped with a small charger like this or direct charging hookups for a larger battery. In addition to the charging equipment, we have vent capability in the back to ensure that gases don't build up to an unsafe way, and the container handles that and can safely offboard gas away from an area where it would be dangerous. These robust doors prevent any gas or flame from exiting the locker in a way that would be harmful to the platform, other equipment, or personnel in the area. And after an event were to occur in one of these lockers, we have the sailors or soldiers or Marines not go inside. They don't need to deal with it, to have to deal with those hazardous products. They just lock the locker out, and it can be removed from this frame and thrown away, and a new one replaced.
Threat Tracker is an autonomous detection, tracking, and classification system. We aim to detect the UXS space, so this is unmanned aerial vehicles, surface vehicles, as well as personnel. With the prevalence of commercial drones and how easily they are available and weaponized, this is a problem area that Threat Tracker aims to provide a solution for. So what would happen is that we have a detection sensor, such as a radar or RF based, that would detect the drone. We would then slew the camera over to it, apply machine learning and AI on it to basically get a classification of what the target is, and then that would be passed off to some type of command and control system or mitigation solution to effectively take care of the target.